This video is going to review how to find or describe the reflections of a function. Now, the reflection of a function is referring to the negative in front of your function. Now, the location of the negative is important because that's going to tell you where it's reflected, which axis it's reflected over. So if the negative is on the outside of the function, which means it's not inside any brackets, any absolute value, any parentheses, or there is no parentheses, it's on the outside, it's affecting the y. So when the negative is on the outside, it affects the y coordinate. Which means it's going over the x-axis. When the negative is on the inside, it affects the x, which means it's over the y-axis. So an example, we want to write g of x, the transformation of the absolute value of f of x equaling the absolute value of x, compressed horizontally by a factor of 2 and reflected in the x-axis. So this will be a quick review of our dilations and our transformations. So here, remember, we have f of x equaling, we'll have our a times the absolute value of x minus h plus k. So it's going to be in that format. So this is compressed horizontally. That means we have a horizontal movement. The a is on the inside, and the a is a 2. So I'm going to have g of x equaling the absolute value. We're going to put 2 on the inside. I'm going to put the x here as well. It's reflected in the x-axis, so it's going over the x-axis, so it's affecting our y. So I'm going to have a negative on the outside. And I don't have any other transformations. It's not translated up or down, right or left. So my function would be g of x equaling the negative absolute value of g of x. So let me just write that one a little bit clearer. So that doesn't look like a 1, so it would be a negative on the outside. Next one, write g of x, the transformation of f of x equaling the absolute value of x stretched vertically by a factor of 2 and reflected in the y-axis. So again, I have g of x. It's a stretch vertically, so that means that's on the a is on the outside. My a again is 2. We're going to have an x on the inside, and this is reflected in the y-axis. So it's reflected across the y-axis. So that means it's affecting our x. So it means I have a negative on the inside. Now when you look at it, when it's graphed, it's going to seem like it's just moving one direction. It's still above the x-axis. But there is a reflection because it's just reflecting over the y-axis there. So that is a quick review on reflections of functions.